Hi students, I am Sandhya, Assistant Professor, Department of Mathematics and SNS College of Technology. Today we are going to see the quadratic form was given. In this quadratic form, we have to convert it into the principal axis. Okay, so here the quadratic form. So in this previous class we learned what is quadratic form. The quadratic form is nothing but the second degree, that is homogeneous of second degree polynomial of any number of variables. Here see the variable is x1 and x2. So in this quadratic form we have to convert it as matrix. So in this converted as matrix already you know how we can find it is a converted into matrix. So that diagonal elements we have to write, that is x1 square is 17 and x2 square is 17. So the remaining one, that is x1 into x2 is x1 into x2 is minus 30. So in this minus 30 we have to divide it by 2, that is minus 15. So here also x2 into x1 is same, that is minus 15. So if it is a matrix is given, we have to find the eigenvalue and the eigenvector. So in this problem it is a 2 by 2 matrix. So the characteristic equation is lambda square minus c1 lambda plus c2. You know c1 and c2. So we can find c1 and c2. c1 is sum of the diagonal element, that is 17 plus 17 is 34. How we can find the c2? c2 is determinant of A. In this 2 by 2 matrix, the determinant of A is AB minus BA. So 17 into 17, that is 289. So 15 into 15 is 225. So the formula is having the minus, so we put minus. So 289 minus 225 is, what is that? Yes, it is a 64. Then we have to substitute the C1 and C2 here. So that is lambda square minus 34 lambda plus 64. So this is the characteristic equation for the given matrix and also the quadratic form. So then we have to solving this. That is the equation is we have to find the eigenvalue. So we have to multiply one number is, we get the value is 64 and adding the two number, the answer is minus 34. So what is the eigenvalue? Yes, the eigenvalue is, yes, very good, it is a 32 and 2. Okay, so we have to using this eigenvalue we have to find the eigenvector. What is the formula for eigenvector? So eigenvector is, yes, it is a given matrix minus that is scalar into identity of x equal to 0. Here the x represents the eigenvector. So in this matrix we have to subtract the eigenvalues, the two eigenvalues. One is 2 and one is 32. So in this diagonal only we have to subtract the lambda value. So here 17 minus 32, that is minus 50. Here also 17 minus 32 is minus 50. Then see the two equations are same. So if it is two equations are same, how we can use the cross rule? Yes, if it is take the substitution method. So 15x1 minus 15x2 is equal to 0. So minus 15x1 equal to 15x2 is, okay. So here the x1 is we have to using the coefficient, that is 15. Okay. So here 15 get cancelled. So we simply write 1. Okay. So here x2 is this coefficient of n. So here the vector is 1 minus 1. Similarly, we have to using the lambda equal to 2. So after the subtraction of the lambda value, that is 2. 17 minus 2 is 15. Okay. So here also 17 minus 2 is 15. So here also the two equations are same or different? Yes, the two equations are same. How we can say it is a same? Here we take minus outside. So here also minus 15 and plus 15. So in this minus value is multiplying into 0, the answer is 0. So the two equations are same. So if it is two equations are same, we take substitution method. So in this 15x1 equal to 15x2. So here 15 get cancelled. So x1 equal to x2. So x1 coefficient is, yeah, that is we have to use in the cross. So x1 is 1 and x2. So these are the two eigenvector for this matrix and the quadratic form also. Then we have to find the, in this quadratic form is into the principal axis. So principal axis is the new coordinate using from the cross product. Okay. So here the principal axis is x equal to y, if it is a x's, x1 and x2. So y is also y equal to y1 and y2. You know n is a normalized eigenvector. So using this eigenvector, we have to find the normalized eigenvector. In this normal eigenvector, so 1 square and minus 1 square is root of 1 square plus minus 1 square is root 2. So we put that is 1 root 1, okay. So 1 root 2, 1 root 2, here also 1 root 2 minus 1 root 2. So this is our n matrix, that is normalized model matrix, and y is also y1, y2. Okay, so next we have to using the q value, that is here already you know q equal to lambda 1 y1 square plus lambda 2 y2 square is there. Here the lambda value is, what is the lambda value? Here the lambda value is 2 into 32, isn't it? So we have to replace, that is 32 or 2 or 2 or 32. But here q, what is q? Here the q is divided. So this is our q, okay. So here we have to replace q instead of 128. So here 32 y1 square plus 2 y2 square. So here we have to divide by 128 divided by all this. So 125 divided by 128. So 128, 128 we cancel. This also divided by 64. Okay, that is 32 divided by 128, that is s. It is a 4. Here also 64. So here y1 square divided by 4 and y2 square divided by 64. So it is ellipse, yes. So the ellipse equation is, what is that? y1 square divided by, that is we use y1 square or y2 square, x1 square divided by a square, and y2 square, that is x2 square divided by what is it? b square equal to 1. So here also we have to convert it as square. So y1 square divided by 2 square and y2 square divided by 8 square. So this is equal to, this is the ellipse equation, okay. So in this quadratic equation, we are going